And I can always double check that by multiplying, let's see, this times this, 2x squared, -4, +1 makes -3, 1 times -2 is -2. So check it out. Once I got a set equal to 0, I use the zero product property to solve, and I know that x equals -1/2 and x equals 2. And just by my cruddy drawing over here, this kind of looks as though it's at x equals -1/2, depending on my scale, right? Excuse me. And this kind of looks like x equals 2. Again, I'm a horrible artist, so we know. Now remember, solutions are points. They're not just x values, and they're not just y values. They're actual points. So I have to name the point. Well, that's nice because I've got y, right? I know that when x equals -1/2, I know that y is going to equal 2 times -1/2, squared. -1/2 squared is a fourth, times 2 is a +1/2. And then this is y equals, when x equals 2, this is just 2 times 2 squared, which is 8. So I want to write this all pretty. So my solutions, I know that there are two of them, is -1/2, 1/2, and 2, 8. And again, even with my lousy drawing, I can see what's going on there. Nothing to it. Okay? All right. Now, watch how ugly this can get, though, if you're not really, really careful. How about this one? How about x squared plus, I actually stole this one out of the book because it's kind of fun to look at. We go x squared plus y squared equals 13, and x squared minus y equals 7. Now, what are we looking at here? It's clearly a system. There's more than one equation. There are a couple of variables in there, right? They're clearly not linear. I'm not looking at two separate lines here. Well, what's this guy? It's a circle. Okay. What's this guy? It's a parabola. Uh-oh. Now, whoa. Before we start sketching and trying to wrap our brain around this, how many ways, how many types of solutions can I get if I've got a circle and a parabola floating around out there in space? Well, let's look. All right, so I could have, let's just draw my circle. This is a radius of root 13, right? Now, is it possible to have no solutions? So let's change some colors. Is it possible to have 0 solutions? Well, yeah. If my parabola does this, my parabola does this, true? So then I get 0 solutions. All right, we change colors again. Is it possible to have exactly 1 solution? Well, yeah, if my parabola touches here, or if my parabola is wide enough that it comes in here and touches and then takes off again, I can have 1 solution. 1 solution. Is it possible? I may have to redraw. Yeah, this is going to get too ugly. Is it possible to have 2 solutions? Ooh, that's not a bad circle. I mean, there have been worse. Let's put it that way. 2 solutions. What would that look like? Well, looks something like that, wouldn't it? So I can have 2 solutions. Oh my gosh, this is getting out of hand. Solutions. How about 3 solutions? Can you see how there'd be 3 solutions? Well, yeah, it's kind of like this guy, only where my parabola isn't wide enough. So it starts here, goes click, like that, and here, and goes click, like that. So there's 3 solutions. And then last but not least, with the ugliest red ever, is it possible to have 4 solutions? Absolutely. Like that. That's how you get 4 solutions. Now I got 1, 2, 3, 4. So I could have as few as 0 and as many as 4 solutions in this problem. However, we're going to find out exactly how many solutions we have. But there is one caveat here. You got to be really careful because we're going to use techniques in this that can get out of hand pretty fast. You're going to be squaring and doing things like that, and you may end up with extraneous solutions. So be careful. Now, I'm going to rewrite it just so I'm not doing algebra over the top of this cluster I got going here. Let's see, x squared plus y squared equal, God, it really hates to write pluses when the screen's big. And then I got x squared minus y equals 7. Now, what's the obvious thing to do here? I suppose I could solve for x squared in both equations and then do a substitution. I don't want to solve for a y because then I got to square stuff and then I'll end up just in a nightmare. How about let's do elimination, because I see that I've got an x squared and an x squared. Now, when I teach this in Algebra 1 and Algebra 2, what I tell them to do is I say, I hate negatives. In the way that I respect thy negatives, I turn my negative into a positive, and I change everything's sign so I don't do anything stupid. That means these x squareds are going away, and I end up with y squared plus y equals 6. So I end up with y squared plus y minus 6 equals 0, and I get y plus 3, I think that's right, and y minus 2 equals 0. So y equals 2 and 3. Now, the question is, how do I end up with 4 solutions if I'm going to get 4 solutions? If y just equals 2 of these things. Watch. Works itself out beautifully. If y equals 2, I'm just going to plug everything back into this guy because, well, I guess it doesn't really matter. I guess I could stick it in the top one too. Watch. When y equals 2, doesn't that imply that x squared plus 4 equals 13, which implies that x squared equals 9, yuck, which implies that x equals plus and minus 3. If y equals 3, then x squared plus 9 equals 13. And you can see by a puff of algebra, that's going to imply that x equals, well, let's see, I subtract, I get 4, take the square root, x equals plus or minus 2. So my solution, in this case, there are 4 solutions. Now, just like in algebra, if you don't believe yourself, double check them. Because every now and then you can get extra solutions by squaring stuff, which can break loose. Like in this case, let me change, just because I see students do this all the time. Do you see how if I solve for y in this equation, I will get, let's see, if I solve for y in this equation, I will get y equals x squared minus 7. Now, if I plug this guy back into this guy, then I'm going to have to square this. And when I square it, I'm going to end up with extra solutions. And that's when all hell breaks loose. But I didn't do it that way, thank God. I used elimination. So let's write our solutions real quick. I know, let's see, I'm going to get x equals positive 3 and y is 2. I'm going to have x equals negative 3 and y is 2. I'm going to have x equals positive 2 and y equals 3. And x equals positive 2 and y equals negative 3. Whoops. Let's try that again. Negative 2 and positive. I fell into my own trap, you guys. Be really careful with these signs because it gets really confusing, as you can tell. Negative 2 and positive 3. And that is my solution. That's good times. All right. One last gooey, nasty thing, and then well, yeah, let's do it real quick. Watch this. How about if I had something ugly like 3 over x minus 9 over y equal 5, and 1 over x plus 2 over y equals 2. All right? Now, what does that even look like, right? I mean, I suppose if we had to, we could solve for something, but this is just going to be a strictly algebraic process. And the beauty is the process doesn't change. It's the exact same thing that you learned back in algebra and in Algebra 2. So notice I've got a 3 over x and a 1 over x. I want to make those go away. So I'm going to multiply everything by negative 3. And that implies that I get 3 over x minus 9 over x equals 5. And then I end up with what? Negative 3 over x minus 6 over y, equals negative 6. And I'm going to add. Right? These cancel. I end up with negative, whoa, that should have been a y right there. Sorry about that, you guys. I know you're going to yell at me in class for that. That happens. I end up with what? Negative 15 y-ths, if there is such a thing, equals negative 1, which implies what? Do a little cross multiplication, you end up with y equals 15. If y equals 15, doesn't that, let's go this way, doesn't that imply that I like to deal with the most simple equation because I have a tendency to do the least stupid things. 1 over x plus 2 15ths This thing's really jerky today. Equals 2, which I'm going to turn it into 15ths anyways, right? This is going to be 30 15ths. They're the same. So 1 over x equals, if I'm subtracting 28 15ths, is that right? 28 15ths, which implies that x equals 15 28. And these are my two solutions. And just like before, I can double check them. I can plug them in. If I need to check, you know what? Let's just do that. If I go, I know you guys hate this. If I go 3 over 15 28ths, what, minus 9 over 15 is equal to 5. Well, watch what I'm going to do here, you guys. I'm going to do a trick. This is a fraction, and I'm dividing by it so I can take the reciprocal. All right? So here we go. 3 times 28 15ths turns into what, 84 15ths? 84 15ths minus 9 15ths, last I checked, was equal to 75 15ths, which equals 5. Checkaroo. Just like in Algebra 1, it's just that we're dealing with uglier looking things. All right. Don't panic. Play, use those algebraic techniques that you've become so good at in the last couple of years, or not. No, I've seen you guys do algebra, you're good. I'll see you in class tomorrow, and write down any questions that you have, we'll discuss them. So have a good day.